Okay, so this is section 5.2, parallel and perpendicular lines. So you're going to need to pause your video and write these vocab words down. So parallel lines are lines that are on the same plane and they never intersect. The symbol looks like two L's or two parallel lines. Perpendicular lines are lines that intersect at 90 degrees. They have to be a 90-degree angle. The symbol looks like a set of perpendicular lines or an upside down T. And a transversal is a line that intersects two or more lines in the same plane. Okay, so I know you've talked about some of these things before, but today we're going to work with different angle measurements and how to solve them. Here is an example. This is not on your paper, but here is an example of a real life example of parallel and perpendicular lines. So what is this a map of? Columbia. Specifically, mainly downtown Columbia. So you'll see when you start driving, and before you start driving, you need to be paying, if you're not already paying attention to how to get places while you're riding with your parents, you need to start paying attention because you're not very far away from driving. And you would have to know how to get places other than always having to use a GPS. You don't want to have to do that every time you get in the car. So if you're not already paying attention to roads and what they intersect with and how to get places, then start. Like today, start. So a lot of cities, if you look at a map of their oldest part of the city or the downtown area, most of the time it's going to run on a perpendicular and parallel grid. So if you learn what roads go north, south, east, or west, or what roads are parallel to each other and what roads are perpendicular to each other, it's a lot easier for you to get somewhere without GPS, okay? So for example, if I want to go somewhere on downtown on Broadway, it's a lot faster for me to turn on Walnut and not have to hit every light on traffic on Broadway. And then when I get close to where I'm going on Broadway, then I would make a left to cut back over to Broadway, if that makes sense. So another example, this doesn't go as far as this on your map, but let's say you're on I-70 and you get off on you get off on Stadium Boulevard, right? That crosses I-70. Where are you at when you get off right there? What are you by? If you get off on Stadium off I-70. Something you guys probably go to quite a bit. Maybe not now with COVID.
Is it the mall?
The mall, yeah. So if you get off I-70 onto Stadium, you're right there by like the mall or like Chick-fil-A, Old Navy, that part is all right there. If you, instead of getting back on Stadium and going back to I-70, if you go the other way, like if you're in the mall parking lot or Chick-fil-A parking lot and you take a right, where are you going to get to?
So like, what are you talking about? Like,
off Stadium. You're on Stadium Boulevard. Where are you going to eventually run into?
Aldi's and stuff?
That's Business Loop or Grindstone. What's at the very other side of Stadium Boulevard? So one side is I-70. What's on the opposite side of Stadium
I don't
Boulevard?
know. The only other way I think I get to Posville is crossing the highway.
What highway?
By TJ Fridays, you go to that highway? Is that what you're talking about?
That's Business Loop.
Well, I don't know.
But that's okay. Okay, so what I'm trying to get at, I thought somebody would know this, but when you go all the way down Stadium, on one end of Stadium is I-70, on the other end of Stadium is Highway 63. Like you get out off on Highway 63 on the other side of Stadium, you go past campus and all that. So that's something that's good to know, the fact that Stadium happens to run into both I-70 and 63 at some point. So you got to kind of know those roads so you know where you're going to end up, because those are two very different highways that take you in a different direction. So you got to start paying attention to that stuff. So anyways, all right. We're going to look at identifying congruent angles. So we're going to list them out first is what we're going to do. And I'll show you how to write them. So if you look at this picture and this picture, here are your parallel lines. And then that one going diagonal would be your transversal. So in order for this to work, you have to have two parallel lines cut by a transversal to have all of these angles be congruent. So if you look right here, it's color coded. So angle 1 is congruent to angle 4. So here's how you write that. Angle 1 is congruent to angle 4. Angle 1 is also congruent to angle 5. And then angle 1 is also congruent to angle 8. Okay, so now we'll move on to angle 2. So angle 2 is congruent to 3. What's congruent mean? Anybody know what's congruent? Equal or the same? Angle 2 is congruent to angle 3. Angle 2 is also congruent to angle 6. And angle 2 is also congruent to angle 7. Okay, so if we move on to angle 3 is congruent to angle 2. We wrote that down just backwards. Angle 3 is congruent to angle 6. We didn't write that yet. Angle 3 is congruent to angle 7. Okay, go to angle 4. Angle 4 is congruent to 1. We already wrote that. Angle 4 is congruent to angle 5. Angle 4 is also congruent to angle 8. This will make a lot more sense when we actually put some measures, like some degrees like of angles on here. And then let's look at angle 6. Angle 6 matches up with 7, I think is the only one we haven't covered. And then 5 and 8 we haven't written down. Angle 5 is congruent to angle 8. Okay, so on that very next one, I think it gives you basically, it's showing you the same exact thing we just did. So we're going to skip that. And we're going to take a look at this picture, these pictures right here. So these are different reasons the angles are congruent. So if you look right here, and I kind of draw a Z with my parallel lines. So if I look at that as like a Z, the insides of the Z across from each other are parallel. Those are called alternate interior angles. If I draw a Z right here, the outsides of my angles are congruent to each other, and that's called alternate exterior angles. And then here, if your angles are located in the same position, like both of them are in the top right corner of the angle, then they'd be corresponding. So those are just different reasons that angles are congruent. We've also learned a couple others, like vertical. Vertical angle was when they are right across from each other. They share a vertex. What about supplementary? What did supplementary mean? Anybody remember? They equal what? Add up to equal what?
90.
That's complementary.
180.
So 180. What about a straight line? What's a straight line equal? 180. So we're going to use all those things, okay? So in this problem, we're going to find the angle measurement. A is parallel to line B, and we are given one angle. So being given one angle, we should be able to find all the other 7. So the first one we're looking at is, what is angle 4? 74 degrees, because they're located in the same position. What's it called when it's located in the same position? We just learned that. When they're located in the same location, it's called corresponding. So we're going to write that. Okay. Angle B, not angle B, angle 3. How would I figure out angle 3? Yes.
74 180 minus 74.
Correct. So 180 degrees minus 74 degrees is going to give us angle 3. So what does angle 3 equal? 106. Okay, and then what's that called when two angles add up to be 100 or be 180? What's that called? Supplementary. Okay, the next one is angle 5. How could I figure out angle 5?
Doesn't 1 equal the same thing as 3?
1 and 3 are the same.
So 1 and 5 would be the same too.
1 and 5 would be the same. So what is angle 1?
106.
106. I wrote 160, didn't I? That should be 106. So then angle 5 has to be 106. And what's that called when they're in the same location? Corresponding. So angle 5 has to equal 106 degrees. And guys, there's a lot of times more than one answer for the reason. There's not more than one answer for the number, like what the angle is. But a lot of times you can justify different answers for the reasoning. It's not always like one way and that's it. Usually there's many options you could take, okay? Okay, so we're gonna go through and do this again. So starting off, we are given one angle and we're gonna go through and find the measure of angle 1. So that's number 2. So the measure of angle 1. How would I figure that out? 180 minus what? 118. And what does that equal? 62 degrees. So this one is 62. And then why does that equal 62? What's that called? Supplementary. Okay. Number 3, we're looking at angle 4. How would I figure out angle 4? Anybody know? Yeah.
Aren't they just the same? Isn't it just the same as 1?
Yes.
Yes, it's the same as 1. So it's 62. And why is it the same?
Corresponding?
Correct. Okay, so now let's look at angle, so number 4 is angle 6. How do we figure out angle 6?
It's the same as 1.
It's the same as 1, not the same as 1.
It's 5.
Same as 118. And those, if you look at it like a Z, those are considered alternate exterior. Alternate exterior angles. And then the last one, number 5, we need to find angle 7.
It's just 118.
It's not 118. It's 62
Oh,
because it's directly across from angle 4. What's that called when they're directly across from each other?
Alternate. Interior.
Starts with a V. We learned it the week before Thanksgiving.
You have it.
I think you just said it. Did you say it?
Vertical?
Vertical. When they're right across from each other, that's called vertical. Okay, I'm going to give you one of these to do on your own. So we already listed out all of these that are congruent. We don't need to do that again. I would like you to try this one. So number 7, 8, 9, and 10. So you'll need to pause your video and go through these problems. All right, so let's go over these. So for number